h. Okay, so most of the time, 99% of the time when you're dealing with limits, you always want to start off with step one being direct substitution. So you want to plug into everywhere there's an x, see what happens to the numerator, see what happens to the denominator, and if you get a number, then that's your answer. But if you get 0 over 0, this is what we call indeterminate form. And indeterminate form can be anything. It just kind of depends on which one's growing faster and how much faster. So most of the limit questions on this page, when you try direct substitution, you're going to get 0 over 0. So your next step is you've got to think of some algebraic trick, some algebraic gymnastics here to rewrite this without changing its size. And then we're going to try direct substitution again. So a lot of times that's factoring, sometimes it's conjugates, sometimes it's trig identities. That looks like about all that we've asked you on here. But in this particular one, this is a complex fraction. We have smaller fractions within a bigger fraction. And so we need to know how to deal with those for a number of different reasons anyway. So complex fractions, I would really love to multiply this by 2 because it makes this smaller fraction go away. But you can't do that unless you're willing to multiply everything by 2. It's like multiplying the top and the bottom of your fraction by 2, which is like multiplying by 1. But just because I multiply everything by 2 doesn't mean all the smaller denominators go away. I still have a smaller denominator of x. So I'd really love to multiply this one by x to make this smaller denominator go away, but mathematically that's only equal if you multiply all the terms by x. And there's probably a dozen mathematical things that you need to know how to do complex fractions for. Just turns out that limits happens to be one of them. So I've done nothing with limits so far. I'm just trying to rewrite this. So I multiplied all of these by 2 by x. Since these canceled, it left 2 times 1 here. Since these canceled, it left a 1 times x here. And down here, this guy didn't have a denominator, so nothing canceled out. And so I have 2 times x times the x minus 2 that's been there the whole time. So the algebraic manipulation that I did was I simplified my complex fraction. I multiplied all those terms by the least common denominator. Now, usually that's enough. So now we start with direct substitution again. Unfortunately, this time it looks like the numerator still goes to 0 and the denominator still goes to 0. So simply simplifying this was not enough. In fact, it's always going to be 0 over 0 until you get something to cancel. Okay, so with that in mind, I can see that my denominator has an x minus 2. Well, my numerator has a 2 minus x. So positive 2, negative x, negative 2, positive x. They have the exact opposite signs. And if they have the exact opposite signs, we have this algebraic trick where we can factor out a negative. Notice if I distribute my negative, I would have a negative x and a plus 2. So I'm not changing it, I'm just changing the way it looks. And I wanted to do that because then something cancels, and now that something cancels, direct substitution is probably going to be fine. Got a negative 1 on top and a 2 times x, but I'm plugging in a 2 for that, so negative 1/4.
Wouldn't taking the negative out make the 2 positive?
This 2?
Or
I only factored the
like
negative
this.
out of the numerator.
So it wouldn't switch the 2 sign?
The quick check is just that when you factor out a negative, just distribute it and make sure that it's equivalent to your previous step. I mean, I guess you could factor a negative out of your denominator too, but then you're just like causing a different problem. So anyway, so that's a little bit longer, but again, if you're comfortable with complex fractions, then really the only thing was realizing you needed something to cancel so that you would think to factor out a negative.